Solid. Okay, obligatory hello, welcome everyone to Wednesday Lab, September 30th. Welcome to my Twitch stream. So I think that's the...
So
I'll just share my screen, I guess, unless there's something that Jose wants to say.
no, I was just saying that I think the poll is done by now. There's a strong agreement on going through problems 4 and 6. So do you want to start with problem 4, the Monty Hall one?
Monty Hall. Let me boot my MATLAB and I will share it right away. Weird thing about this file, the solution file is called my new car, but the function is called my Monty Hall. It doesn't matter. There we go. MATLAB's open, and I'll share the link. I'll stop sharing the results now. 4 and 6, we remember. More. And share screen. My Monty Hall. Behold. Stop for a moment while people take a screenshot. So we discussed a little bit the skeleton code on Monday. So it's before I start, actually, let me just I should probably make Jose the host and then open breakout rooms in case there's any like side questions. So like, let me stop share for a moment. So create rooms manually, and I'm gonna assign Jose to a room just temporarily, just so I can open the rooms. But other than that, open all rooms. Yeah, Jose, you don't need to go to it right now. But I'm just making the rooms. Wait, give me 1 second. Let me add more rooms. Now I'll open all rooms. Okay, and I'll make Jose the host. If I can find you under participants. Okay. I still have control of the recording. People joining us asynchronously, we're still working things out. It's the first time, so it's fine. All right, back to Monty Hall. Screen share this if screen cap this if you want. Basically, it's like we went over in the on Monday skeleton code. You start by, and I'll just kind of explain this, but you can kind of see what the code's trying to do in the meantime. So you have the win counter, which is tracking the number of wins. So we have, let's say, 100 simulations, 100 sims. We have a guess, which is either going to be stay or change. If you've done this already, you'll know that change is better by a factor of 2. Oh, my mistake. This is a method. Let me erase this. This is method. And your guess is going to be, I don't know, 1, 2, or 3. One of those doors. The door you're guessing. So let's start counting our number of wins at 0. Before we run the simulation, nothing happens. So here, this for loop right here, ends here, runs number of simulations from 1 to 100. Let's do this 100 times. Let's have 100 contestants, and they'll each decide to either stay or change, depending on their method. So here, randomize the door that the car is behind. This will be 1, 2, or 3, because each guess we plug in, no matter what it is, it can be 1, 2, or 3. It doesn't change the final result. We're going to pull that, and we're going to say, okay, is our guess equal to our car? For each of these if-else statements. But first, we'll need to randomize what car is. We're going to put it under one of 3 doors, door number 1, 2, or 3. And we'll just compare our guess, let's say 1, to that car, and see if they match up. So there's 2 win conditions, and that's what these represent. Win number 1 and win number 2. In all other cases, we lose. We get a goat. We don't want a goat. We want a car. If the method is stay, use string comparison, not the double equal sign, because they're strings. You can't compare change to stay because there are vectors of different lengths. So you do that string comparison. If you stay, if you stick with your initial guess of door number 1, and your guess is equal to your car, that is, the car is also behind door number 1, then we win. We get a brand new car. Another way we win is if we change and we start with door number 1, but the car is behind door number 2 or 3. But it doesn't matter if the car is behind 2 or 3, because Monty Hall is going to open one of the doors that the car is not behind. Like this is us, and this is the car. If the car is behind door number 2, he's going to open 3, and if the car is behind 3, he's going to open 2. So whatever happens, if we change and the car is not the one we initially picked, then we win. Win condition number 2. And that's all for our simulation. Now, this last line here is just collection. You have a win rate, WR, is equal to the number of wins, just the win counter, over number of simulation, let's say 100. Say. Okay. We are not going to get exactly equal to like the theoretical probability for each of these simulations. They're just simulations because it's random. But we should get something like about 0.33 or 0.66 about for stay and for change. I'm not spoiling anything. You guys can look this up. Those are the probabilities for the Monty Hall paradox. If you want, you could try this for, you could swap random int just for fun. I'm going to put this in a different color because this is just for fun. Change this to like 4, 5, 100 if you want, just to play around with the number of doors and see like how much better the change is in all those scenarios. Control Z. Have I not covered anything? Yeah, I think the format short, this part over on top is just to kind of trim the win rate to like a few decimal points. You don't want this to be like 0.3456 or anything. You can if you want, but that's not, I mean, this is not necessary. Like the format short, it's just for display purposes. You won't be graded on that. Your win rate does not change depending on your display. So I think you had a previous lab that kind of did that. Okay. So if you want these notes, go ahead. I'll give you guys a few seconds to kind of take a screenshot of that. Okay, closing it in 5, 4, 3, 2, 1. Now I'll stop for any questions. Let's see here. Is equal work instead of string comparison? I think so. I would need to check that. Hold on. I think so. I think I've seen code that does that. Okay, I'm pretty sure it does. Let's see. What else? Journalize we went over. Okay, so on so someone's asking, so generalize what we went over on Monday. So Monday we just went over skeleton code for the